In this video, I'll explain you what is meant by potential. I deleted the. Okay. In the last video, I have explained you what is potential at a point. That is nothing but work done in bringing a charge, that is unit charge, from infinity to a point A. So in this video, we will do a derivation to get the exact value, to check whether we have done in the last processes right or not. Okay. So we have a source charge Q here. So as per the definition, what is the definition? Potential of a point in an electric field is the amount of work done in carrying a unit charge from infinity to that point. So let's say we are going to find the potential at this point, which is A, and the other point is at infinity. Okay, so one thing is very clear. Do we actually need to do work, to move a small distance from infinity to a nearby point? We will see. Okay, now when we have to do work, whenever we are applying a force and there is a displacement in the direction of force. So work done is equal to force into displacement. Now at infinity, what will be the force? We have a charge which is at infinite distance away from the source charge. So here basically for small distance we don't have to do work, correct? Because at infinity electric field will approximately be 0. So E, what is the value of E? E is equal to Q by 4 pi epsilon 0 into 1 by distance of this point from the source charge. Now this will be infinity and E will be infinity. So E will be all value divided by infinity 0. So basically E is 0 here, force is 0. Now we know that as we move from infinity to position A, the force will increase. Why? Because electric field will increase in this direction. Okay, so in this direction electric field will decrease, in this direction electric field will increase. Now one thing is very sure, the force here at infinity is 0. So from here it will be a small value increment, small value, again force will increase. So at different position, to keep the charge going, we have to apply different force, because this is a varying electric field with respect to a source charge. Now in this process we have to do integration. Whenever it is variable force, then equation for work done is equal to integral from position 1 to position 2 F dot ds. Clear? It's a variable force, right? From infinity till A. So this is the equation we have to do. And we will substitute the values in this equation. Now work done is equal to, so we are going to find the value of Q charge. After that we will divide it with Q, so that we will get the value of potential. So this is for Q charge, and when we are dividing it with Q, we will get it for unit test charge, unit positive charge. Now the value from infinity to A will be integral. What is the first position? Infinity. What is the next position? A. And how will we get force? What is force? Force is nothing but these are two charges, right? Capital Q and small q. From Coulomb's law we know the force in between two charges. What is that? 1 by 4 pi epsilon 0 Q1 Q2 divided by R square. Now we are considering that we have reached somewhere in between and the position is at this position, it is R. Now from this position R we are going to take a displacement of dr. So just this is very simple. While integration we have to consider arbitrary points. Now let's say the charge is at this position at R distance away from the source charge. Now from this position we are going to have a small displacement of dr, so that F force at this position into the small distance will be giving us the work done in that small area. Okay, so integration, what do we mean by integration? We will consider that these 2 points are very close to each other, so that force doesn't vary much. Now what we will do, we will find F force at this position into dr. Similarly we will find another 2 points, and we will multiply force at that position into that dr, and we will multiply. So this we will do for all the process, and after that we will sum all them together to get the total work done from infinity to here. Okay, so that is the process of integration. So this is 1 by 4 pi epsilon 0 q divided by r square into dr. That is for a small displacement of dr, this value without integration. When we are integrating, we are adding up all the value from here till here. Okay, cool. Now this is dot product, right? We know one thing, that is force is in this direction and our displacement is in this direction. So what is the angle in between these two? Which is 180. Okay, so this dot product will be A dot B is nothing but mod A mod B cos theta. So this will be cos 180. What is cos 180? Minus. So this dot product, I'll take it as next step, infinity to A 1 by 4 pi epsilon 0 q by r square into dr into cos 180, which is minus 1. So I'll take all the constant to this side of the integral. Which are the constant? 1 by 4 pi epsilon 0 is a constant, and q is a constant. Yeah, and minus is also taken out. We have from infinity to a integral of 1 by r square. I am going to take it as r power minus 2 into dr. Now how can we do this integral? So x power n integral is raise the power by 1, x power n plus 1 divided by n plus 1. Right, integral of this one is this. So with that concept, this will be equal to minus, we have outside minus 1 by 4 pi epsilon 0 q into q into what is the integral of r power minus 2? R power minus 2 plus 1, that is minus 1 divided by minus 1. That too with the limits infinity to a. So I will take this minus 1 out, and minus will cancel, and this will only be now positive q divided by 4 pi epsilon 0 into, now r power minus 1 is 1 by r. What are the limits? Infinity and a. Okay, now how we will substitute the limits? First we will substitute the upper limit, then we will substitute lower limit and subtract these two. So q divided by 4 pi epsilon 0. First substitute the upper limit 1 by r a. Then substitute the lower limit 1 by infinity. And what will be the value of 1 by infinity? 1 by infinity is 0. So what is remaining? kq. And one more thing, this is only work done, right? Whatever we have found out is just work done. Okay, now to get the value work done of q charge, now to get the value of unit charge, we have to divide it with q. We have to divide all the equation with q. Okay, now I will take this equation this side. So I am substituting the value for 1 by infinity as 0. So the total work done wq is equal to, what is that value? q divided by 4 pi epsilon 0 into 1 by r. Clear? Now this is the total work done. Divided with q, we will get the value for one test charge, unit positive charge. Both are same. Okay, whenever I am saying unit test charge and unit positive charge, is the same thing. Okay, so these q will cancel, and the value will be q by 4 pi epsilon 0 into r. So this is the VA. This is the value we have derived in the previous case. So you can use both the derivation, but whenever it is asked for 3 marks and above, use this derivation. Okay, because we have more contents here. So the other one is just a two-step process. But for memorizing the equations, you can use the other equation. But while derivation, when it is asked in your question paper, do this equation and you will get more score. Thank you.